Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything we can write the requirements for.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
The X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
Your Air Force is continually developing new and more astonishing aircraft.
We have the air, we have the power.
The development of new power in the air has brought about terrific speed.
The diving of subsonic airplanes at speeds for which they were never designed could be a hazardous business.
Knowledgeable men were seriously wondering whether man could ever fly faster than the speed of sound.
It remained for the high-speed flight program to attack these problems with scientific facilities of a new kind.
Rifle and artillery shells had been traveling supersonically for many years. The XS-1 was indeed shaped like a .50 caliber bullet.
Through the sound barrier, the first time ever in level flight.
Blazing through sound barriers and now heat barriers, the Bell X-2 reaches the unheard-of speed of 1,900 miles per hour.
The D-558 was the first American aircraft to use swept-back wings and stall fences. The primary mission of the X-3 was thin wing research. The X-4 was its lack of a horizontal tail. The X-5 could sweep its wings in flight.
Pilots achieved a 7-1 record over the MiG. The United States Air Force played a vital role in holding the line against communist aggression.
Step by step, these different aircraft helped nibble away at the unknown until the frontiers of manned flight had been advanced from speeds of 500 miles an hour to Mach 3.
It was long before Sputnik that we decided to build the X-15. This was a logical step in the research aircraft program, the first hypersonic aircraft.
What is to be man's role in space travel? Can he pilot an aircraft out of the Earth's atmosphere, fly it in space, then re-enter the atmosphere and bring it back to a safe landing on Earth?
Designed to investigate the problems of manned flight in a near-space environment, there were many unknowns to be discovered, many problems to be overcome. Hypersonic flow of air would heat the leading edges of the plane to 1,300 degrees Fahrenheit. How could the pilot control the aircraft in air so thin that normal aerodynamic control would be impossible? No engine like this had ever existed before.
The 50,000 pounds of thrust in a single chamber had to be controllable at the pilot's discretion.
The X-15 pilots flew to study the physiological aspects of high-speed and high-altitude flight. The data gathered proved to be invaluable to follow-on missions beyond the Earth's atmosphere.
They have dramatized the potential of piloted high-performance aircraft in a space environment at a time when much of the world's gaze was turned toward orbital flight.
The aeroplane has become an important means of commercial transportation and a decisive weapon of war. Air transportation helps our economy.
The United States is only about 5 hours wide.
Research programs investigate flight at ever greater speeds as time and distance shrink.
A supersonic transport must be durable, and it cannot itself cost too much. controversial XB-70 gathers invaluable data on stability and control characteristics.
We were flying two YF-12s with a whole lot of supersonic, high-temperature research, and the F-111 pack airplane, which contributed greatly to the knowledge of the transonic regime.
A cross-country flight that would take you minutes instead of hours.
The X-43 is a revolutionary new kind of airplane. What we want to do with this is prove that hypersonic flight with an air-breathing engine is possible.
Do Mach 3.
Though the technology exists for aircraft to fly at speeds faster than the speed of sound, today's aircraft don't.
If an aircraft is flying from New York to Los Angeles, the sonic boom will be heard consistently across the country.
We're talking about commercial operations. You're having, 40 in a day.
Would be breaking windows or at least annoying a lot of people.
We can in fact shape the airplane in such a way that we can shape the sonic boom and it sound different.
This project is looking to put instrumentation for the air crew to see where the airplane is booming the ground at. It's a real-time map display overlaid with the boom showing where it's hitting the ground.
Supersonic.
It's that pullout that puts the quiet boom out on the area of interest.
Foxtrot, bird, thump, thump. Spike 3, thump, thump.
The end goal is to create a quiet supersonic aircraft.
With the X-59 program, we're going to be gathering a series of data from communities around the U.S. relating people's response to the noise to the sonic thumps. We're hoping that the data that we gather with X-59 will convince the regulatory agencies to change the no supersonic overland flight rule.